Hey guys, how's it going? Hope your week's been going well so far. I want to do a little bit of new stuff. So if you can get your notebooks out, we're going to do some division that we haven't done in a long time. We're going to do some long division, but we're going to divide polynomials, which is what we've been working with for probably about a month now. So for instance, our first example is going to be dividing 2x plus 1 and 6x squared plus 7x plus 2. So if you remember long division, we put something near the top of that divisor sign, and we multiply it by the piece out front. And so ideally we're trying to cancel a 6x squared right now. We're trying to make that 0. And I have a 2x out front. So if you think about what times 2x gives me a 6x squared, it's 3x. So what do I do with that 3x? I'm going to multiply both by the 2x and the 1. So 3x times 2x is 6x squared. And 3x times 1 is 3x. And then we subtract those, if you remember long division. And the whole idea is that as you go through this long division, you want that first term, in this case, the 6x squared, to become 0. And it does. So we do 6x squared minus 6x squared, again, is 0. Then we're going to do 7x minus 3x and get 4x. And we're going to bring down the 2, the positive 2. So then we go back to the very top, and we think what times 2x will give me a 4x, because now we're trying to cancel a 4x. So what times 2x is 4x? And that's a positive 2. So we're going to multiply 2 times 2x and get 4x, and 2 times 1 and get 2. Subtract these, and we get a remainder of 0. You're not always going to get a remainder of 0, but if you do, what it means is that your original divisor of 2x plus 1 and your result 3x plus 2 are factors of 6x squared plus 7x plus 2. And again, you can only say that if your remainder is 0. And if you missed any part of that, just ask Miss Winfield to stop and rewind, and I know she will. Let's do another example. Let's take 4x squared plus 23x minus 16. And we're going to divide that by x plus 5. So we're trying to cancel the 4x squared. So we have to look at the x all the way out front. So what times x gives me a 4x squared? And that's 4x. So what do we do with the 4x? We're going to multiply by the x plus 5. We're going to distribute that. So we get 4x squared and 20x. And then we're going to subtract these. So the 4x squareds cancel. Again, that's the whole point. And 23x minus 20x gives me 3x. Bring down to negative 16. So then what times x will give me a 3x? Hope you're thinking positive 3. So again, distribute the 3 times the x plus 5. So we get 3x minus 15. Plus 15, sorry. We're going to subtract these. The 3x's cancel. And negative 16 minus 15 more is negative 31. And that's our remainder. Which means that you cannot say that x plus 5 and 4x plus 3 are factors of 4x squared plus 23x minus 16. Depending on the type of problem you have, you can also do something called synthetic division. The last two problems were long division. So let's say I ask you to use synthetic division to divide x cubed minus 14x squared plus 51x minus 54. And we're going to divide that by x plus 2. So right now I have it written like a long division problem. And we need to rewrite this long division problem as a synthetic division problem. So the first thing we're going to do is we're going to reverse the sign of whatever that value is with the x. So which means we're going to write a negative 2. So somewhere below that example you just wrote, write a negative 2, and we're going to sort of keep it off to itself and put in like a half box. We're also, next to that half box, going to start writing the coefficients of the polynomial. So the coefficients are 1, negative 14, 51, and negative 54. So that's step 1. Step 2 is we're going to bring down the first number, whatever that number is. So bring down that first coefficient. Step 3 is we're going to multiply what we have inside that half box by that number that we brought down. So in this case, negative 2 times 1 is negative 2. And we're going to put it underneath the next column. And then we're going to add those. And then we're going to repeat that process until we're done. So now I'm going to take the negative 2 in the half box times a negative 16 that we just got. And I get a positive 32. If I add those, I get a positive 83. Again, go back to that half box, the negative 2, and multiply by the 83 we just got. And that gives me a negative 166. And we're going to add those again, negative 220. So now we're ready to look at the answer for this. The very last column is always your remainder. So I know my remainder in this problem is going to be a negative 220. The rest, the coefficients of 1, the negative 16, and the 83 at the very bottom, we need to put variables with those. And since the original problem was x cubed divided by x, I know there was other stuff there, but we're only going to focus on that first term. X cubed divided by the x out front. Overall is x squared. And then we're going to keep on lowering that by a power. X to the first. And then we don't need to write it, but we could write an x to the 0 after the 83. In other words, if you were to divide these two using long division, the quotient or the result would be x squared minus 16x plus 83 with a remainder of negative 220. And so you might be thinking, man, that looks like a lot of work and that's really confusing. It's probably only because you've never seen synthetic division before, but you have seen some sort of long division before. It turns out that usually synthetic division is a lot faster than long division. And so if you're doing something a little bit faster, then there's a better chance that you're not going to make a mistake. For now, I'm probably going to ask you to do one versus the other. So if you're given some sort of homework, it might say, use synthetic division to find blah, 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 or use long division to find, etc. So I'm going to stop the recording, and if you have any questions, feel free to send me an email. And what I'll do tonight, if I get your email in time, is I will record another lesson if need be to try and answer any questions you might have and go over any of these examples that you need to see again. So hopefully things are going well, and I will talk to you guys soon.